Greetings and welcome to my video exploring some of my own practical applications of procedural audio. Procedural audio is nonlinear, often made possible through different forms of synthesis, created in real time according to a set of programmatic rules and live input. This method of sound design and music was originally introduced to me by Jean-Luc Sinclair. I highly recommend checking out his lectures on jeanlucsinclair.com. That's JEAN-LUC. And I have to tell you, pearls of knowledge just fall off of him, and you do a lot for yourself if you just check out his lectures or if you have the chance to meet him in person. But I owe a lot of my education on this topic to him. So there you go, JL. I just gave you an unsolicited plug. Now, my video in Ableton has been a little choppy lately, so I will be showing a bounce of a clip from the movie Rob Roy. I've stripped all of the original audio and replaced it with an array of plugins utilizing procedural techniques. So, enjoy. Now you may have noticed the lack of ambient sound in ADR. Ambience and ADR are a little too complex of sounds for this demonstration. However, that does not mean that they are impossible. For simple ambiences, the procedural audio process would actually be an ideal candidate. The problem becomes a processing issue the more complex the ambience becomes, and it may be easier to use audio samples instead. I prefer to use this method for repetitive sounds that require a randomized effect, where you can get close to 5,000 variations from one program. In this way, efficiency takes precedence. I'd like to begin this demonstration with my sword patch. Let's check it out real quick. As you can see, I have it mapped to a MIDI, and each of these sliders is also mapped to these macros. You can do it other ways, but I prefer to do it in this way so I can have better control over it. Now, duration and slide would be more sword scrapes, and the longer that you set this, the longer the sword scrape will be. Hardness is usually attributed to the impact, and brightness controls how many overtones are being excited. You can actually change the weapon by changing the brightness. It may not continue to be a sword, but it may turn into another piece of machinery or a hammer or any other metal object. Let's listen. Let's up the hardness here. Now you can hear actually getting more distorted. So you have more overtones that are being excited. Let's make a longer slide. If you set it all the way down, it'll actually give less of a sword sound, since typically when you're hitting two swords together, there's going to be a little bit of a scrape, but it sounds like more of a tap. If you set all the way down, then it'll even sound just like a light tap. Let's mess with the brightness real quick. See, it starts getting more muffled, and you may be able to get different representations of different, maybe different swords if you'd like. But I like to think of them as like hammers and other pieces of machinery. Let's actually open up the patch real quick. All right, let's put it into presentation mode. Now, as you can see, I was a little bit messy with my patch here. I'm usually a little bit more clean with my patches, but for this, I just wanted the demonstration of showing its ability and having it sound good. So I kind of started this with two different patches. I started it with the carpal strung, as you can see over here, but only a portion of the carpal strung. Carpal strung is usually used for physical modeling and imitation of strings. I just use the excitation portion of it, the noise burst part of it, and you can use more physical modeling if you choose to use it, but it does create more processing. And if you have a very powerful computer, I highly recommend exploring physical modeling. It is a lot of fun. It is a lot of math, but it definitely does create some very interesting sounds. And actually, carpal strung, because it is used more for strings, it is used more for music. But I was using this for the sake of sound design, and I wanted to demonstrate this for sound design because I think that sound designers would actually benefit from being able to just play in the sounds using MIDI and have them randomized, and rather than just dragging and dropping all these different audio samples. Now, the initial impact comes from MIDI, and it sends a randomly generated signal input. And this is where the randomly generated signal input, this is where the MIDI comes in. If you can kind of follow around my cursor. Hardness actually adjusts the center frequency of the single pole filter. So the single pole filter, both this signal input from the impact and the noise burst from the carpal strung are run through this one pole filter. And so if you look at the hardness, you can follow it down. Right here does it adjust the one pole, but it also adjusts the amount of overdrive, so the amount of distortion being played through, and that actually is a portion of what you're hearing in the little ring out. it's actually only a select few, and from the looks of it, about three different different bandpass filters. And brightness, which actually you can find over here, at least you can find a slider over here. But when you adjust the brightness, it actually controls the frequency of the rand object, which is right here, and which is essentially just a noise oscillator. So if you adjust the brightness, it's going to lower the bandwidth of the noise oscillator, so you won't be getting some of these higher frequencies. Duration and slide pretty much just controls all of the filter. I'm sorry, not the filters, the envelopes in this. Mostly for the resonating filters, it basically opens and closes the audio outputs for those. And as you can see, I'm using resin, the resin filters here. And here's a fun little thing that you can actually do. So you hear it, but this is how versatile you can actually be in this. Let's open this real quick. So this second from the last one is actually your center frequency. And if you change this, oops, not move it, you change it. I apologize. So you change this frequency to whatever you'd like. And we're going to change a bunch of them actually. Now I had this specifically set for the sound that I wanted, for basically the sword that I wanted. But if you change these, you can actually get some very interesting things. And I'm just being completely random here. There's no specific ones that specific frequencies that I'm particularly aiming for. But if we can just lower this a lot quicker, it would save a lot of time. I suppose I could just input it, but I like just showing that you can actually just source slide it. And here's some of the higher frequencies, and let's bring some of those down. Now I've actually seen some people take sort of the same idea, the sort of metal sounding idea used through modal synthesis. And I've seen like buttons in which it'll actually randomize these. You just hit like a button and it'll randomize them, and you'll get different sounds. See, as you can see, it sounds completely different. Yes, it still sounds metal, so to speak, but it actually is it sounds like a different type of metal being hit. Let's move on to my next patches. Next out here. No, I don't want to say that. All right, let's move on to my whooshes. My little whoosh patch. And there's only one slider for this one. It's lightness. And so the lower that you have it, the bigger the object sounds, the one that's being swung. The higher it is, the higher it sounds. So let's listen to it right now. Oh, nope, not that one. We need to change it. So you have like a nice low whoosh there. And the fun part about this is that it does sound a little random. It's still low, but it doesn't it's not the same every time you play it. So here's a higher frequency. As you can hear, it's much quicker. So let's open up this patch. Let's drag it over here. As you can see, it's also a little confusing, but I'm sure that you guys can follow along with this. It's not too difficult. It's mainly this that just looks like it's out of place. I apologize for my computer looking like it's being a little sluggy. It usually isn't this bad, but we can definitely work with it. Now, the whoosh is actually essentially a noise oscillator running through a bandpass filter. Lightness controls the center frequency, and the drunk objects make the center frequency, the drunk objects right over here, make the center frequency, the Q, and the gain wobble randomly. So the sound is more randomized, but it's still controlled. So rather than just having like just a rand number on here, drunk just makes it sort of wobble sort of back and forth depending on what frequency I set it to on the lightness. And here's the little bandpass filter. You can see it moving all about. There you are. That's pretty much how it works. Now let's move on to my fire patch. Now I didn't actually create this patch per se. It was actually conceptualized in the book Designing Sound by Andy Farnell. I highly recommend checking out that book if you're at all interested in this kind of stuff. He uses PD instead of Max, and I'd like to thank my friend Mark for translating them into Max MSP. He pretty much took well, not all of them, but most of the practical examples that are built in PD and translated them into Max. Let's look at the fire ambience is what I called it. As you can see, this is even more crazy. Here you can actually take a quick look at it. There's a lot of sub patches in here. I'd rather not go through all of them, but I did change a few of the values, mostly just right around here, to change kind of the size of the fire, because obviously in the video you only saw torches. So what this originally sounded like was more of a giant bonfire. So there was a lot of low end, there was a lot of lapping, and I just wanted to make it so it was a little bit more controlled. It sounded lighter. It would fit the scene a little bit more. But he approached the sound in a very, very interesting way. I'd highly recommend reading that book, because he does go through different scientific ideas of how the sound is actually being created, and then he actually translates that in PD. And obviously we are using Max here, and PD and Max are too far removed from each other. And actually I use a bit of the footsteps. I altered them a little bit to my own liking. I made them sound a little bit more short sounding, like you're stepping on kind of stone with a little bit of tiny bit of gravel on it. So it sounds more like shoe scuffs rather than the original one, which actually sounds like you're stepping into sand or gravel, like a full step into it. This is also in the book Designing Sound, so I highly recommend checking that out. I'd like to move over to how I created the sword patch in PD. So let's move over here. Let's make sure I've got everything. Yep, I do. Now, this essentially, I created this after the max patch. And I created a sword patch to PD so I may be able to integrate it with game engines. As you can see, it's a little more cleaned up and a lot more sub patches. So let's get those into the front real quick. So you have impact, attack, and this is just so it looked more clean. So I could set these things a little bit more individually, so I don't have to go searching on one page for it. I know exactly where each one of them is. Some of the sub patches have additional sub patches within them. Let's see if I can find my ring. There's one more sub patch. And here it is. And that's all my, that's a portion of my, my filters, my bandpass filters for the modal synthesis. And I aim to be able to get feedback from the game to change different parameters and essentially work, and for it to essentially work itself based on the strength of the swing, the material the player is hitting also, and how much scraping is involved. So let's actually listen to it real quick. So we need to set this real quick. We need to turn on the digital signal processing. Let's try not to get too much slide out of this, but let's bring up the brightness real high. Now I apologize if this may be loud. It does seem pretty loud to me. As you can see, there's a lot of distortion in there. And I'd like to work on it just a tiny bit more to possibly get it a little bit more under control with the distortion. I do kind of like how the distortion is adding these extra weird sounding overtones, but I'd like to get it to where obviously this is a prototype at the moment, and I'd rather just get it working in some game engines. I've been looking at I looked at Fract. Fract is actually a video game in which you create the music as you play. It's more so shaped like a first-person shooter, and you activate these different parts of the music, and you basically create your own music. I highly recommend checking out. But if you actually, I like this idea of being able to put this into a game, because you can change the bandpass center frequencies, and you could have just one program for arrangement of different equipable swords for the player, and it could take in as much information as you choose to do, and all of this is done without taking up any memory within the game for samples, and all of it is being generated by the game. Now it does mean that it would be taken a little bit away from the processing power, but because PD does seem to run pretty light, I don't see it as being a very huge issue. But anyway, that's my entire video, and hopefully you can check out some more of my stuff. I hope to post some of these things, maybe a little bit more in depth for the nerdy folk out there, and you can check all this stuff out on stevecarrollaudio.com. Thank you.